on polynomials, and what did you guys notice with question 1 if you were asked to factor this one? Why is this one a little easier? What did you notice about this expression?
Only 3 terms.
Only 3 terms, and what's my highest, what's the word degree mean? Exponent, what's my highest exponent? 2, which means it's a quadratic. Yes, yes, yes. Anybody know what you got for those factors to be? Want to share with us today? What do we find our factors to be for question 1? Anybody? I saw so many good responses. Like Cameron, I think I saw you get it. What'd you find your factors to be? How does that sound with everybody? Does that sound good? Okay, great. So what if you, like when you have your quiz next week, if you're asked to factor, how can you always check to make sure you got your factors correct? Yeah, just multiply it back through. And then you would be able to see like, oh yeah, I got these right. I'm on the right track. Now with question 2, what did you maybe notice from the beginning with question 2? Did anybody notice anything about question 2 from the beginning?
There's 4.
There's what?
4 terms.
There's 4 terms. What else did you see? Greatest common factor. Liam, what did you find the greatest common factor to be? 3x. Great job. So from there, we're going to use kind of that idea Morgan said. 4 terms, so you would have factored by grouping. And if you got that far, what did you find your factors to be? What did we find our factors to be once we got that far? Saw lots of good responses. Sabina, what did you find your factors to be?
2x squared minus 1 and x plus 3.
And x plus what?
3.
How does that sound with everybody? All right, and Alex asked a great question, too, and just wondering about, like, can you keep factoring here? What did you guys notice? Could you keep factoring here? Could you keep factoring any of these? No, you would have really wanted to check in on this one squared. I can't keep factoring this because 2 is not a what? A square number. Good. And that's what we're going to get into first today. We were kind of a little like unsure sometimes with our difference of squares. So we're going to get in first today with our factoring of sum or difference of squares. So this is review, right? We all know if you had 2 terms with a difference means what sign? Subtraction. So if I have a subtraction between my 2 terms and they're both perfect squares, then you'd be able to factor it into like a plus b and then a minus b when you started off with a squared minus b squared. So kind of think about why that would make sense if you're looking at this quadratic here, x squared minus 4, right? What would your b term really have been if there's no b term? What does that mean if there's nothing? 0. So think about you had to add up to 0. And how are you going to add up to 0? When what you're multiplying to, which would have been -4, has to be the same number, just different signs. So think about that's going to happen when I have -2 plus 2. Okay, that multiplies to give me 4 and adds up to 0. So that's all still kind of the new stuff, or that's review stuff that we all know. Let's build on it a little bit more with kind of ideas from last time. So why don't you guys take a minute, jot down these 2 questions, and then we'll go through these examples. So jot down both of them because we're going to kind of go through both of them back to back. So looking at our first question, 18x squared minus 50. So I see there's 2 terms, but are those numbers right now perfect squares? No, what might I consider looking at what I have? What do you see, Yalda?
The GCF.
Awesome job. GCF here, they're both even numbers, so I know 2 is for sure going to be a greatest common factor. So, or not a greatest common factor, a common factor. Maybe it might be more, but in this case here, it's not. We're left with 9x squared minus 25. And notice 9x squared and 25 are both those perfect squares? Yeah, so what are those factors going to be?
3 equals 5, 3 equals 1.
Great job. And then check each of these. Can you keep factoring those? Nope, they're those linear factors. All right, next up we have x to the fourth minus 16. Okay, 16 I know is a perfect square. Is x to the fourth a perfect square? Yeah, what times what gives you x to the fourth? X squared times x squared. So what would my factors become? Think about perfect square of both of those. Great job, Evan. X squared plus 4 and x squared minus 4. And now, have we factored all the way? No, what do you see can still keep factoring?
Squared minus 4.
Great job. X squared plus 4. Bring it right on down. There's no way that can keep factoring because there's a plus sign. And what would x squared minus 4 factor into?
X minus 2 and x minus 2.
Great job. And now we have factored all the way. Once again, if that was like a quiz-like question, remember you could multiply those 3 together to kind of make sure you came back with your final result. What other questions do you guys have here? All right, let's keep building on. And now we're going to get to kind of new factoring, which is going to be sum and difference of cubes. So notice with perfect cubes, if you have 2 terms and both of them are perfect cubes, you can do this with either the sum or difference. So it doesn't matter in this case here if you have a minus or a plus sign. Notice your 2 terms should be perfect cubes. So with that, kind of notice the setup here. This is going to be a formula that you're going to need to memorize. So everybody, definitely make sure you're jotting these down in your notes. So with each, notice your A's and your B's, this whole setup is really the same. The only thing that's changing between if you have a minus or a plus is the sign between each term. And how we're going to remember the sign between each term is this acronym called SOAP, which SOAP stands for same, opposite, always, positive. So let's go through and kind of break down this formula. So I'll have kind of first with your minus, if you have A cubed minus B cubed. So thinking about both of those are perfect cubes. Your first factor is going to be the cube root of both of those terms with S meaning the same side. So I'll still keep my minus sign. And my second factor is going to be a trinomial. So I'll have 3 terms. And it's going to come from my first term being that A term all squared. And then I'm going to have my middle term have the opposite sign. So now I'll have a plus here. And my middle term is A times B. So always remember that middle term. I always say middle, multiply the 2. And then your last term is AP, meaning always positive. And it's that second term, meaning this B here all squared. So it's just a formula you kind of got to know to plug in. And noticing the same thing with our second example, when you're using a plus sign, the only thing that's changing is the signs, right? So same sign, opposite sign, always positive at the end. So take a couple seconds, make sure you definitely have that jot down somewhere in your notes, and then we'll look at some examples. All right, anybody need more time? All right, so take a minute, jot down these 2 examples, and and then we'll work through them. Alright, looking at our first example, you have x cubed plus 64. So, are both of those perfect cubes?
Yes.
Yeah, both of those are perfect cubes. So let's start to kind of break down how we're going to use that formula. So let's take the cube root of each of them. So what's our cube root of x cubed? Just x. So you're going to think about that like the a value in your formula. What about what's the cube root of 64? Cube root of 64 is going to be 4. Oh, 8 would be the square root. So from here, using our formula, my first factor would become what? X plus 4. Awesome job. Think about I'm using my same sign. Now my second factor is what our first term is going to come from this first term and my first parenthesis group all squared. So think about it would be x squared, which I know will just be x squared. Now my second term has the opposite sign, which means I'll have what instead? A minus. And anybody remember what the middle term is? Oh, it's a times b, which means x times 4, which is 4x. And then lastly, I'm always positive, which means plus. And my last term comes from this b, which is 4 squared, which would end up being what value? 16. Good job. If you get that number, just don't write it as 4 squared. Actually do 16. And I know x squared minus 4 plus 16, I can't factor anymore, right? Because is anything going to multiply to positive 16 and add to negative 4? No. What questions do you guys have with that formula? Just kind of plugging it in. All right, let's look at our next example. You have 8x cubed minus 27. So we already talked about x cubed, perfect cubed, obviously. What about 8 and 27? Are those perfect cubes? Yeah, what's our cube root of 8x cubed? And, sorry, I'm about to see. And what's the cube root of 27? 3. So let's take our formula, and what would our first parenthesis, that first factor, become?
2x minus 3.
Great job using the same sign. So it's 2x minus 3. What's my first term going to be in my second parenthesis group?
4x squared.
Great job. Our just did a great job of squaring that whole term. So think about it's 2x all squared, which means 2x times 2x. So that's probably our biggest little mistake that I'll see students make, is just kind of putting a square on your variable. So don't forget to square that coefficient as well. All right, next up I'm going to have the opposite sign, which will be a positive plus. And my middle term would become what? 6x. Good job. A times b. And then my last term is always positive, and it'll become 9 because 3 squared. All right, what other questions do you guys have here? All right, why don't you guys try these next two problems, and then we'll go over them, and then we'll do some classwork. All right, you guys, let's go through these two. And what did you notice about the first question? How many terms do you have? 4. So if you see 4 terms, what should be your method of factoring? Grouping. So you would have factored out 4x squared, and then you would have had x minus 3. And then when you're here, notice you want those to match up, but the signs don't right now. So you factor out a minus 1, and then you have x minus 3. So a lot of you guys got here, which is amazing. 4x squared minus 1, then x minus 3. But remember, we're next leveling it. So you don't just stop right here, because what can we still keep doing?
4x squared minus 1.
Yeah, 4x squared minus 1 can keep factoring, and what do those factors become?
2x minus 1 to the first one.
Awesome. That is that expression factored out all the way. So let's look at our second question, and what's your first thought when you saw these? Think about it, like 2 terms, so what's always like kind of first check for? Greatest common factor, what was our greatest common factor here?
-3x.
Great job. The -3, I think it is definitely helpful to factor out, right? Because then kind of getting rid of both those minus signs, and then what is it, 64?
X cubed plus 1.
Alright, so if you have 64x cubed plus 1, can we keep factoring this? Yeah, think about this minus sum, because it's a plus of, and they're both perfect cubes. So question about this guy, this GCF. Just bring that down in front, kind of along for the ride. And what would my first factor be? Think about what's the cube root of 64x cubed?
4x.
Good job, and I heard 4x plus 1 already, right? Same sign. Cube root of 1 is just 1. Now, what's my second factor going to look like? What's the first term?
69 squared.
Great job, and my next sign is going to be opposite, so it'll be a minus. My middle term is?
4x.
Good job, and then last we are? Awesome job, guys. So I would say these are kind of like quiz level type questions when you're thinking about factoring, right? You're not going to just factor once and be done, kind of think about, you'll factor once and have some more to do, kind of like how you had with both of those. So that's it kind of for our notes today. What questions do you guys have?